CC-1 Contact Insertion Counter is an RFID-based system for tracking the performance of your device test kit in production test. The device test kit includes the load board for your test system. It also includes the test sockets and any other components that may be difficult to track electronically. The CC-1 system consists of the CC-1 module, a microantenna per socket, and sometimes a microantenna on the load board. The microantennas can be connected to the CC-1 module by either 50 ohm cables or by 50 ohm PCB traces. CC-1 can be mounted directly onto new load board designs, or it can be mounted onto a universal adapter board for use with existing load boards. The USB interface provides power and communication. This drawing shows a CC-1 connected to the microantennas through 50 ohm cables. This method is used when installing the CC-1 onto a turret handler. It can also be useful in an engineering lab where temperature chambers or thermostreams are used. When a cable interface is used, the microantennas are self-contained. Each microantenna is mounted onto its own PCB. Their small size makes them easy to fit close to each of the test sockets. The connector is a 50 ohm surface mount MMCX. CC-1 can be installed using a vertical form factor. This minimizes the area taken up on the load board or UAB. Or it can be installed using a horizontal configuration. This allows for installation when there is minimal Z-axis clearance between the tester load board and the device handler. The small communication module next to the CC-1 simplifies the addition of the CC-1 to the load board. The communications module contains the USB interface and other support circuitry needed by CC-1. In both the vertical and horizontal configuration, CC-1 and the COM module are mounted using pogo pins, so only one set of modules is required per test system. This drawing shows a CC-1 RFID system mounted onto a load board. This is an existing load board shown in light green. We designed a custom microantenna board to mount onto the customer's load board, shown here in dark green. The microantenna board is 0.4 mm thick FR4 PCB. It is customized by Microtesters to fit the customer's test socket pattern. The microantenna circuits are surface mounted onto the antenna board, while the RFID tags are mounted onto each of the sockets. CC-1 and its support module are mounted onto the right side of the antenna board. This configuration enables us to add CC-1 to your existing test kits without modification to your existing load boards. Let's begin the simulation. This simulation duplicates our CC-1 demonstration kit. For the purpose of this demonstration, we'll be using a load board as it was mounted onto a test system. There is one RFID tag mounted on each socket. There is a microantenna located on the load board to communicate with each tag. There is an additional RFID tag epoxied onto the load board. All antennas connect to the CC-1 through 50 ohm traces on the board, and finally out through the ribbon cable. We connect CC-1 to the test system or to the test cell controller through the USB cable. Before interfacing the test system to the handler, CC-1 inventories the test kit. CC-1 has detected a fault. One of the sockets is not compatible with the devices that will be tested. The socket is replaced and the test kit is re-inventoried. The system is mated to the handler and testing begins. After testing for a while, CC-1 issues an alert. One of the sockets has reached its maximum number of insertions and requires maintenance. This issue could have been avoided during setup by comparing the number of insertions left on each socket to the lot size of the devices to be tested. At this time, the user may elect to replace the socket or to continue testing and replace the socket later. This user is replacing the socket. Before changing any of the test kit, CC-1 updates each socket with the new insertion count. The socket in question is replaced and the test kit is inventoried. Testing resumes. At the end of lot, all sockets are updated with the new totals. The user's database can also be automatically updated at this time. The RFID tag on each socket contains its history. Now that the sockets can be reliably identified, the user can add socket and load board serial numbers to the data log record of all the devices that were tested. This is useful to identify sockets that yield lower than their counterparts. We can identify these problematic sockets before they become catastrophic. Adding CC-1 to your test methodology increases test quality by providing traceability for the entire test setup. Thank you very much for watching, and please visit www.microtesters.com to learn more.